Good evening, everyone. Thank you very much for joining today's session. Yesterday, I took you through machine learning basics, and we studied. I took you some of the motivation machine learning is relevant these days in industry, and not only in industry, in academia, in the health industry, and then even in finance. How machine learning has been utilized to automate a lot of tasks and specifically in finance to optimize profit and all that. So I also took you through unsupervised learning and supervised learning, where I made mention that supervised learning simply means that you have a collection of data sets which are already labeled, and with this your labeled data set is simply known as the response variable, or here your your targets. And I also took you through unsupervised learning, mentioning some of the algorithms that are mostly used for unsupervised learning. And then we went on to reinforcement learning, and as well as some of the technical things that you're supposed to know in these very course. I think it took you through some of the machine learning timelines too as well, where it all started from and where we are now from 1764 to 2018, the transition of machine learning and some of the notable people that we should be uh, aware of. And I think I spoke a lot about Geoffrey Hinton, who actually introduced deep learning concepts, and he actually formed he is the one who pioneered the whole idea of the deep learning. So, and I gave you some links to check out on some of the articles that is written and how useful it's been to industries, and not only that, as well as in academia. Okay, so I think today I'll start with the Google Colab document, and then please make sure that you make use of the links that I sent you yesterday. All right, any questions depending on how I work things out. And then on Monday and Tuesday, I'll come up with a schedule. If you have any personal questions that you want to ask, any technical questions, any question that has to do with the program from month one all the way to the month we are in now. I mean, whatever you need to go along with us, you can feel free to ask them. So I'll make myself available for you guys, hopefully tomorrow and Tuesday. So I hope you've all downloaded the Google Colab file now. Have you downloaded it? If you've done that, just show a thumbs up in the chat box.
Yeah, downloaded.
All right. So you have downloaded it. Who else?
Me, I haven't. Just a second.
Yes, kindly do that as soon as possible. Please make sure you download the Google Colab file. Don't assume that you are just coming to follow the session and then after that you make time and then watch the video. It is imperative for you to download it and then follow along. Once a cell, you run it along with me. Then I'll explain every line to make sure that you grab the concept and what each line of code is doing.
Sorry,
So I think it's very necessary for you to download it.
Is it under assignment or presentation?
I'm pasting the link again in the chat box in case you don't have it. So I've
okay.
pasted the link again. You just have to click on the link and then it will open a tab. Then you just make a copy of it. So you just come click on files. Once you click on file, just go all the way to save a copy in Drive. You click on save a copy in Drive, it will automatically create a copy. Then you work from the copy file. I hope that's clear for everyone.
Thank you. Yes.
Yes, who else is here to do whatever I said right now? Should you wait for anyone? Yes. Why is Oluwa? Is Oluwa in the session? Oluwa Bukola. And
Yes, I
think
am.
other,
Yes, I am.
great
I've
to see you.
downloaded. You're
Is
welcome.
Veronica there? Georgia Safo, are you there? And
Yes, I'm there. I'm there.
I can see Eugene. Okay, Benjani is also here, and then Alap. So you can really download the file, and then we get started. All right. So yesterday I took you to 3 subcategories of machine learning, which is unsupervised learning, supervised learning, and then reinforcement learning. There was the last one that I didn't speak much about, which is normally referred to as semi-supervised machine learning technique. I didn't speak about that a lot because it's not actually a major area of machine learning. It's mostly embedded and sometimes under unsupervised, and depending on the work you are dealing with, is sometimes referred to as classify it under supervised or unsupervised. So it just lies between the intersection of unsupervised and then supervised learning. So today I'm going to talk about just 2 algorithms under supervised learning, which is k-nearest neighbor and then logistic regression. There are a lot of algorithms. I'll just leave them for you to try them out on the same data set that I'm going to give to you now. If you are working locally, then I would encourage you to click on this very link, Arrays dataset, to download the dataset. But then if you are working from Google Colab, there's no need for you to download it. In the second part of this very good Google Colab notebook, I'll be introducing to you the reinforcement learning, which is actually based on creating a game and how machines are able to play a game and receive some kind of reward consecutively, and then they keep maximizing their chances of gaining profit. I hope you guys have played games online before. We sometimes play games with a computer, and then sometimes the computer will win. Those of you who normally enjoy playing FIFA, tic-tac-toe, and other games online, you play the games, and sometimes you win, and sometimes the computer will win you. That's exactly what I'm just going to take you through the whole idea of how those
Hello,
things work.
friends.
Yes.
Hello, friend. Can I not get the Iris data set from sklearn?
Yes.
Or I need to download it
SQLN.
here.
No, we just have to download it. SQLN is just a repository for various libraries. So just click on the link. If you are working locally, just click on the link. Click on this particular link here to open a tab. Then you just download the Google Colab. Sorry, the link for
Yeah,
the
because
data set.
I
Sorry, the
see
data set.
in Excel that from sklearn.dataset import load Iris. So I was thinking that that was trying to.
Yeah, that is why I'm saying that if you are working on Google Colab, there's no need to actually download the file again.
Okay.
That's what I'm saying. Yeah. So there's a portion that saves a lot of data sets, and you also have the MNIST data set and then the arrays data sets. I'm working, the other one is used for image recognition and all that. But then I'm just dealing purely with numerical values today and categorical values today. Yeah, so if you have any other question, please feel free and leave them in the chat box. You need to prompt me, then I'll get back to them.
Please, Prince, can you increase the font of your?
All right.
Yes, thank you. It's better.
All right, so today's objective, we are just going to look at some visualization in Python using Python library, specifically Seaborn, and then Seaborn and then Matplotlib. We look at the difference between machine learning models and illustrate some difference of machine learning model performance and importance of testing. That is, you being able to split the data set into two, one for testing and then one for training. So I'll speak so much about the classification metrics, which are different type of metrics that are used to assess the performance of machine learning algorithm. So these are just relevant outlines that I'm going to talk about. So first of all, you just have to run this cell, which simply load all the necessary libraries. But before that, can you all see connect here, your upper right corner? Can you see this? Connect, click on that, and then it will connect you to Google server. Before that, then you run the cell. You can run the cell with Shift Enter. Okay. That's how you run a cell in the Google Lab. So or whatever you see here, the relevant libraries that will be necessary for our tasks today. The first one is the Pandas library, which contains a lot of functions for loading. For instance, if you want to load data sets into your cell, Pandas, we normally use Pandas. So we have three main type of them. We have Pandas, NumPy, and then SciPy. They are all used for mathematical analysis or in any form of analysis that arises in the field of data science. The second one is Matplotlib library, which contains a lot of functions for visualization. So today we are just going to look at Matplotlib and then Seaborn. We are also going to download the arrays datasets, which is a collection of different type of flowers, their petal size, and then their sepal sizes. I mean, different features of flowers. So that are neatly represented in a data frame. So that's what we are going to employ for our analysis today. And if you run this or this, so it simply goes into the sklearn that just the repository and then imports the arrays datasets. Yes, so the next one is if model selection simply is just it's also a library which helps you to split your data sets into that is train test split. It's a function that helps you to split your data sets into two, one for training, one for testing. And this line of code, what this line of code is simply doing is that we just go into sklearn linear model, and then within linear model there's a module or a function that is the logistic regression function. So you are simply importing the logistic regression function, and that's the same explanation applies to the k nearest neighbor classifier. So remember that one of the algorithm is a regression algorithm, and then the second one is a classification algorithm. So and I spoke about this thing yesterday, that there are two areas of supervised learning. The first area is classification, and the area is regression. And there are different types of algorithms that falls under these areas. Now, if you want to access the performance of your classifier, you need to import the metrics, and we look at these various types of metrics as you go on. So you run this cell, run the next cell again. This use shift enter to run the cell. Someone said I should repaste. Okay. Yes, Benjani, go ahead.
Yes, sorry, I wanted to find out if you are using a local notebook like Jupyter notebook, how would we import this data? Because it's not showing like it's in Excel or it's like it's in a different format, the iris data set.
Yeah, so if you are working locally, you don't need this line of code. You just have to. So it means that you have to make sure that the data set that you're having, and then the collab file is in the same folder. Do you get what I'm saying?
Yes. But
So
it's
I
not
think
in
if you
a,
download the file, it should be in the form of a CSV file. The file you
it's not,
downloaded, is it a CSV file?
well, it's not showing like it's a CSV file.
I think when you download, it's
What type of file is that?
zipped.
A data
You need
file.
you need to unzip it first. It's zipped, so you need to unzip it so that you have access to the document.
Yeah, but even
Uh,
after you unzip it, it's not a
Yes.
CSV, not even an.
It's like it's a data.
Yeah, one is dot data, another one is dot name,
Dot
another
name.
one is index file, another one is again dot data, but with the visit k Irish. So I think the way is being saved is a different format.
Yeah, it's
Yeah,
not
so
a
that means
CSV
that
file, but it's able to read. Python is able to read.
Okay,
Sorry,
Python
come
can read
again.
it, but then what is the extension?
Hello.
Press.
I would
Hello.
like to know the extension first before I can help you guys. Alternatively, unless you work with me on Google Colab, I think that would
Hello.
be the more convenient way to go about it.
Yeah,
Yes.
I'm working locally, and that's why I asked whether you can use the sklearn. It seems like the errors is in the sklearn. So I downloaded a scikit-learn module or the library using the PIP. So
Yes.
after doing that, I was able to import the sklearn dataset directly. So
So that
I
means
didn't
that
need
you didn't download the
no,
data set.
I didn't
You
need
just
to
ran
download
it
the data.
automatically. Okay. So
Yeah,
it means that if you don't have sklearn installed, you
then
can use
yeah,
script to install it, and then
you get
you can also run the saw directly and it will automatically
yeah,
download it.
it's working perfectly here.
Okay.
So maybe they can
But then just try running the cell first. If you run the cell and then it gives you an error, then it means that I hope that's fine, Benjani and the other colleague.
Maybe later on after we're done, I could be helped with the procedure, but maybe for now I'll work with Google Colab.
Okay, that's fine.
Please press.
Yes.
Is it the iris? Is it a data frame? The type of the iris. You say iris load iris. Is it a data frame?
You mean is the data set a data frame? I don't really get you.
Yeah, the type of the first line iris itself.
You mean this one, the second line of code?
The first line.
This one.
Yes.
Just name.
This
Just
one, we are just loading the arrays data sets.
Mhm. Okay.
Is that okay? Can I proceed? So, for instance, if you run this, it will just give you a data set that is kind of messed up. So you have to organize them neatly in a data frame. So have you realized how the data set looks like? So it's a data set that is in the form of a NumPy array. So it's not a data set that is neatly organized in a data frame. The one who just asked this question. So you are just loading the NumPy data frame, the arrays data set that is in the form of a NumPy array. And we load it inside this variable called iris. So once you load it into this variable, it's not really organized. So we have to organize them in the data frame. I think you did this something similar to this in I think month 2 or so, where you have a list of NumPy arrays and you are supposed to organize them in a data frame. Do you guys remember?
Yes.
Yes, so that's exactly what we are doing here. So the next one is the df frame is just the generic way of loading a NumPy files into a data set into a data frame. Which represent this one. And the next one is the columns that we have. And the columns come with features. I think see this thing. Yes, so you realize that we have the target names here, which are which are categorical variable given as so we have the setosa, Fezzica, and then Virginica. So these are just type of flowers, and this actually represents the target variable. So, or is sometimes called the response variable, however you call it. So the data set is it's not really organized, just a NumPy array. So the next one, arrays.data. So arrays.data will simply, so data is simply this one represented in a NumPy form. So arrays.data will just pick whatever I have here. And then the columns in this case, feature names will pick the feature names that have been, I think, illustrated. Okay. Where is the feature names? So the feature name is also given in the data set. So it's just a specific names or the features in the data set. So that will be represented in the column form. As the names given to each of the columns, the sepal and all those things, all the way to the last one that you have. Then it's arranged them neatly. The last one is the targets, which isn't added to the data frame. So we need to add that to the data frame. And I think I met some of you and I told you that if you have a column and you want to add this particular column to a data frame, you just call the name of the data frame, which is DF in our case, and then you bring a square bracket, then you type the name of the column that you wanted to add. And then the next thing is that what do you want that particular column to contain? It should be your target. So arrays.target, array simply means that the name of the data set, the NumPy array that you just loaded into this variable. And if you go into this NumPy array, it contains a specific array called target, which is simply your label. And the labels are represented in numerical values. So 0 represents something, 1 represents something, and then 2 represents something. And I just showed you the various labels that we have, which were actually a categorical value. So categorical variable. So you just call that, and then it will create a new column and save that column in this particular form. Now, df.head is simply a method used to visualize your data frame. So if you want to visualize maybe 20 rows, you just input 20. If you want to visualize maybe just the first 5 rows, you just put 5 in there. But then by default, it gives you the first 5 rows. Now, the first step in a data analysis after loading your data set and then visualizing your data set, how it looks like, the next step to look out for is simply the shape of your data set. So you call your DF again, you call your data frame again, which in this case is saved as DF. Then you pass the method. I mean, this thing, the method, the function. So shape df.shape, and this will give you the shape of your data frame. So here, realize that we have 150 rows and just 5 columns. So if you come here, we have just 1 all the way to your target. From your sepal length to your target, we have only 5 columns and then 150 rows. So let me quickly comment this thing. Are you on the same page? Can I proceed?
Yes, Prince, but I asked one thing. Like you
Yes.
mentioned earlier on, before you even print the iris data, you have already put you said that there is a column called target, and then you put it target before even you do the D head. Then you add it to the first 5 row that you have printed.
You mean this one, this line
The
of
target
code?
one. Yeah. The second one. You know that your GF target iris does target. You added that target to.
You mean this one?
Yeah.
Yes. So this line of code is simply giving you everything without the target column. It will create the data frame without the target column.
Okay.
Let me illustrate it for you to see how it looks like. I think I would have to do the same in the whole processing. So if you comment this thing out and load this thing again. have you seen what is happening here? The one who asked the question. Is he with me? Who asked the question? Oh my God. The guy who asked the question. So if you can see my screen, the second line of code is simply printing out the features of the data set without the target variable. But then we need a target variable, and the best way to add the target variable is to use this particular line of code. So you call the data frame again, and then you pass the target that you want. And I made mention that this target is already given in the data frame that I showed, the NumPy array that has been already downloaded and saved in the iris variable. So arrays.target simply means that there's a section called target containing the target values. So you should save that particular target values as a column in the data frame. That's exactly what this line of code is doing. Are you okay now? Can I proceed?
Oh, okay, so I see that the iris data actually contain two different arrays. One array is for the other data, and then there is a target array also separately on its own inside that
Exactly.
array. That's why you added it to the data, to the remaining columns.
Yes. So that's why I'm saying that the arrays data is not a CSV file. It's not a data frame that has been already created. It's a NumPy array. It's disorganized. So you have to organize them in a data frame. Is that clear?
Thank you, it's clear.
So let me run this thing. I think I can proceed now. So the next section is data analysis, and in this section we'll be looking at the various visualization tools to explore the data set, gain some insight into the data set, meaning, data is simply information. So let's look at the information that have been saved or stored inside the data set that we have. And yesterday, I think Bukola is still around. You asked a very interesting question about what it means for a data set to be noisy, or what it means and what it means. Sorry, what it meant for a data set to be biased. And I think I explained this thing to you yesterday, but then I would like to stress on that again. So it's very simple. When you say a data set is biased, it simply means that the data itself or the process of collecting and analyzing the data is systematically skewed or favoring a certain outcome. So for instance, the arrays data set, you can say that the data was actually cleaned or organized or collected in a way that favors just one label. That means that there's a bias in terms of how the values were allocated or how the the actual data sets were organized. And I made mention yesterday that if a data set is noisy, it simply means that it comes with gibberish, a lot of gibberish, so many things that are irrelevant to our analysis. So it means that it contains random or irrelevant variations, errors or inconsistencies that can obscure the underlying patterns or trends. Maybe you are trying to model something or forecast something, and there's this particular outlier that will interfere with your model or the process of doing your forecast. I don't know if she's still around. If she's still around, she should by now gain a different idea into what it meant for a data to be biased and what it meant for a data to be noisy.
Well, thank you. I'm around. Thank you, Prince.
And yeah, so thanks be around. And this mostly affect the accuracy of your model. And the noisy data set mostly affects, it mostly leads to overfitting. It means that you have this particular outlier in your model, and your model is trying at all costs to distinguish between that particular data point. So it sometimes leads to overfitting. This reduces the accuracy of the model's ability to generalize it between a new data set it hasn't seen before. Yeah, so there are some links here. If you want to learn more about imbalance and balance distribution, you can click on this link and it will take you to a page where you can, a blog post where you can read more about it. Yesterday, I made mention of Pandas, Matplotlib, and Seaborn, as well as Plotly. Then I didn't attach the links to those things. So here are the links. If you want to read more about them, you can go ahead. And I think it's necessary for you to learn more about them and then get what they mean. Yes, so we are still on the aspect of visualization. Then we are starting with a pie chart. Using pie chart to visualize what's actually going on in our data sets. So let me break down what this code means. So the labels which I've already talked about, this of course simply defines the labels for the pie chart slices. So so if you look carefully, you realize that if you look at the pie chart, just the upper right corner is labeled differently from, these are simply labels that will be given to the slices of your pie charts. And then the next one, which is Gen1 equals DF target value. This line simply calculates the count value of each unique values in the data set. And in this case, we are dealing with the target column of the data frame. So you simply create a new data frame and save it in the variable Gen1, and then it counts the informations, all the informations that are associated with each of the labels. So it counts the Setosa labels, all the values in there, and then the other ones as well. So simply, Gen1 simply stores the count values of the target variable. The next one is plt.py, Gen1. So in this case, it means that we are going to simply plot out the pie chart. So this line simply generates the pie chart using the data from Gen1. And here in this case, we are using the specified labels that have been given. So the plt.py is simply a function in Matplotlib, and it creates a pie chart based on the given parameters that we have. And in this case, the parameters that we have are what's simply saved inside the Gen1 variable. So in summary, it simply means that the Gen1 contains the counts of each category, and category which in this case will be the labels that have been given. And auto PCT is simply a way of, it's a format, a way of displaying your values on the pie chart, specifically percentage value of the pie chart on the pie chart slices. So it's a format, it's a way of formatting the values to display them in terms of percentages on the slices. And in this case, just this 0.1 simply means one decimal place followed by a percentage symbol. Shadow in this case, shadow equals to false. It simply determines whether or not a shadow effect is applied to the pie chart or not. So that's simply what this line of code is doing. So yes, thank you. Should be
Hello.
able to
What did you say
validate.
that the PTC is? Is that auto PTC?
Yeah, auto PCT is just a way of formatting the values that you want to appear on the pie chart. So for instance, if you 0.1 simply means that just one decimal place. Okay, and if you do 0.2, it simply means that it will give you 2 decimal places. So it gives you 2 decimal places. And if you look at this pie chart carefully, it simply tells you that the data is not that biased. It means that all the classes have the same count. So the one who asked the question, so AutoPC in this case specify the format for displaying the percentage values on the pie charts, on the pie slices. So basically it formats the values to display one decimal place followed by a percentage value. So if you want a different decimal place, you just have to include 2, then it will print that. So it's just a way of formatting the values on the pie chart. I hope that's clear.
Yeah, so without it, it will not be formatted or nothing will come.
So without it, it means that you just don't need. There are a lot of formatting actually in pie charts. Yeah, there's a whole lot of. If you take it off, it means that those things wouldn't show. It's not the only format function that we have in pie chart. If you take it off, it means that the percentage value wouldn't show.
Oh, so it means
in our case, sometimes you just want to show the numbers on the slices, and then if you want them in percentage, you just use a different format. And then the one I use here is the percentage. So if you take it out, it means that it wouldn't show the slice. Yes, so I think someone was asking a question.
oh, so is it just like a percentage kind of 1 digit before and 1 digit after the percentages? That's the way to format it.
Exactly. So that's the format.
Ah, okay.
Yes. Any other question about?
So if you want to make it degree, I don't know. Are you going to change the percentage into something else?
Come again, if you want to change what degree, I didn't get you right.
If you want to make it degree, like instead of percentages.
If you want to make it degrees as in.
Yes, in angles.
I think this
Oh, that
particular
would
case,
be
we are dealing with numbers. We are not dealing with
Oh,
angles.
okay.
I don't know if I'm getting it right. We are dealing with numbers, and we
No,
want to
you
just
can still do it, but then you have to define the angles. Like you take pi times 360 over 100 to remove the.
Okay. You mean you want to get the angles of the pie
Yes.
chart?
Yeah, he wants to change it instead of percentage. He wants it in angles. So because look at it,
Okay.
looks like a do an angle. So that's where you
So
answer,
that would be a different parameter, actually.
Yeah, you divide by 100, you multiply by 360, and then you multiply by I don't know the.
Exactly. So it means that you would have to do some introduce extra parameters on how to go about that. So in this case, it means that we are just going to get the same angles throughout because the values are of the same size.
Yes, you should be getting same angle.
Well, that's a very good question, actually. Yeah, so in summary, the auto quiz simply stands for automatic percentage. So it's simply a parameter that allows you to automatically format and display percentage value on the pie charts, simply on the slicing that we have in there. So we realize that if I take that off, it wouldn't show again. So this 1.1 I have there simply stand for the percentage value, and it will display one digit after the decimal point. So you realize I have percentage, double percentage there is simply used to escape percentage signs. So the first one is we have 1% sign, and the second one is just to escape it so that it will. Let me see if I bring this thing. So it's print as something else. So in order to let Python, if you enter a percentage, it means something else to Python. So in order to escape it and tell Python that I want this thing to be indicated, then you have to make sure that you use the right one. So the second percentage is just an escape sign. So the one who asked the question, I think you can play more about this and find a way to print out the angles instead of the percentages. And once you do that, you can share it with your colleagues. I hope that.
Yeah, it's obvious. You just define the angles, and then after defining the angles, instead of where it says pie chart, where it says the D, you just put angles, and then where it says auto PCT, that should be
Yes.
none because it's not going to be percentage anymore. That
Sure.
should.
Okay. So you can actually play with these things and find a way to go about it.
Ali, come again. What did you say?
So guys, there's more. I need to finish this. I need to speed up. There's another notebook file that I need to talk about as well. That's for the unsupervised learning. I've not yet started reinforcement, and I think there are other things that you can still employ, do personal research, and also how to go about it. So let me just take you to the basics, and you can spend more time on how to play about it. The main thing about programming is there's a variety of ways of going about one thing. So you can do it in a different way. Someone will do it in a different way, but another, and you are getting the same result. That's the fun part of programming, or maybe specifically data analysis. So it's all about practicing, practicing, practicing. The more you practice, the more you know diverse ways on how to solve a specific problem. Okay. I hope that's fine with all of you. All right, so let me proceed to plotting histogram over all features to check distribution. I think they've already taken you guys through these things, right? If I'm right. Are you guys there? All
Yes,
right.
we are there.
Yeah, so the first line, df.hist is simply a line that generates histogram for all the features in the data frame. And you already know what df means, so which is a function that's a variable that stores the data frame. the hist function is simply a function, or is a function in I think it should be in matplotlib, or I think it should be pandas instead, which it actually creates histograms by default. The edge color, if you look at uh, the histogram that I have there, you realize that the edges are of color black, and that's what the edge color is simply. So it's simply an argument that sets the color of the edges of the histogram bars to yeah, I think to black. The next one, which is the GCF function, it simply stands for get current figure, and it is a function that retrieves the current figure object that represent the entire windows, or the overall canvas of the plot that you want to visualize. And in our case, it will simply retrieve the current figures, or it will just create a new one if you don't, because for this case we have them already. So the figure simply represent the entire windows or canvas of the overall plot.
Does it mean if we don't put the get current figure, it will take another figure from somewhere else?
No, it will not take it from somewhere. It will automatically create one. Is that clear?
Yes, thank you.
Yeah, it will automatically create. And so that's exactly what is happening here. And then the next one is just to set the int, or the size, the set size int, which is in this case I set them to 12 and 6. And PLT does so simply mean that you want to visualize. So in this case, you can know whether your values are normally distributed, or they are following a Gaussian distribution, or just to help you know the distribution of your data sets. That's the importance of plotting the variable features to variable features of, all the features of your data set to check the distributions. Is that clear? Should I proceed? I think I'm doing detailed explanation already, and the time is already gone. So let me quickly speed up. The volume plot is also one interesting visualization tool in math, and is, I think, in Seaborn. This one is not found in Matplotlib. It's a Seaborn library, and Seaborn is simply built on top of Matplotlib actually. And the primary function of this volume plot is to display the distribution of a continuous variable or features across different categorical groups. So it simply combines aspect of box plot. It doesn't only uses box plot, but there's a special type of plot known as the whisker plots. It utilizes those things as well. There's another one also called, if I can recall, I think kernel density also. Yeah. And one interesting thing about the volume plot is that it provides a concise summary of the data distribution, and it allows for easy comparison between multiple categories. So that's an interesting thing about the volume plot. So if you look at the lines of code that I have there, figure size equals to 15 by 10, simply create a new figure object with the specified size, and the size that I have here is simply 15 by 10, which is an argument that sets the width of the figure to 15 inches, and then the height to 10 inches. So the next one, POT, the subplots 2, 2, 1 is simply the line of code that creates the subplots within the figure. So it specifies the figure, the location of the figure. So in this case, we have a 2 by 2 grid. The first one simply stand for a 2 by 2 grid, and the second two represent the location, called the location, that is the row, and then the last one is the column. So if you look at this carefully, you realize that, okay, let me check again. Yes, a 2 by 2 grid, that is for the first one, and then the last one represents the position of your subplots. So one represents simply means that the first one, the second one, it lists them according to rows. And I think this line of code should explain the subsequent ones that I have in here. Yes, so there's a special interpretation to violin plots, which has to do with the mean, the size, and all that. There's a special interpretation to it. So just make time and then play around them, and if you can see very carefully, can you see that um, there's this black, is it black? You see a small rectangle or something in the middle of the plot.
Yeah.
Yes, so there's a very special interpretation to this violin plot. I think we'd have to make time and then take you through this thing. But actually, it simply summarizes the data into box plots. So it's used to show the minimum. I think if I can recall, it illustrates the first quartile, the median, the third quartile, and then the maximum. So something like a probability density function. Yeah. So and each explanation tells you the relevance of a particular data set and what it means based on the first quartile, the median, and then the third quartile, as well as the maximum. So you can make time, and then I'll encourage you to play around them, and then if you have any question, they can inbox me. Okay. Do you have any questions so far to this stage? Are there questions in the chat, Eunice?
Hello, Prince. You would like us to end here?
Yeah. No, I was asking if there are questions.
No, in the chat, I can't see a question.
Hi, Prince, may I ask a question?
Yes, go ahead.
When you plot the histogram, you use the entire data set, the DF. However, when...
Hi, come again. I didn't get you.
Yeah, and then you use the subplot on the other one. So what's the reason? Why didn't you use the subplots here?
I don't get you. You mean
you see on the histogram here,
is,
you did histogram for all data along together, right?
I mean, yeah, this histogram. Yes, yes.
Yes. Why didn't you use the sub? Why do you use the
Yes,
whole
go
data?
ahead.
The whole data set df.hist. However, when you did the one down, you have used Yes, you use the violin, you have used a different approach. Despite there is a DF. So there's no way to summarize this one also like the way you did for the previous one?
DF is absent. When you come to the violin, you have the function with its input parameters. It has 3 input arguments. The first one is X, which simply represents the target. The second one is just, I'm talking about just the labels. And then I'm passing the data. The data here, I'm still passing the data frame. I'm not passing anything different. It's the same data frame, DF. Are you okay? Are you there?
Yes, I can hear you.
Sorry, are you referring to this line of code?
Yeah, no, it's fine then. It's okay since you have already explained. I was thinking why you use subplot here, not up there. And then is there no way also to summarize? Because the other one looked like a summary rather than using
Yeah.
the
Yes, you can. As for the use of subplots, you can. It's just a way of just playing around a data frame. How
okay.
to visualize them. Yeah, so you can apply subplots for this one too as well. Okay, you can just go ahead and then apply subplots. But then this one, I just did all of them in one image, and then just gave the category. And then it just give just a one plot, and then it just arranged them by itself. So you can still play around them, do it one by one. You see, this particular place, it was different for each of the plots. If you want to do it that way too, you can just go ahead and use the subplots for each of the plots.
Okay.
Okay. Yeah. Yeah, that's a very good question, actually. So the next thing I want to talk about is the pair plots. This plot is also very interesting, and it can also be found in Seaborn. And I already mentioned that Seaborn is simply built on top of Matplotlib. So what it does is it simply creates a grid of a scatter plot, and where each variables is plotted against every other variables in the data set. So that's simply what is there. And if you look at the first line of code, SNS dot pair plot is simply using the Seaborn library to create a pair of plots. And this is based on the data frame DF. So that is the data frame that I use, the original data frame that I defined. Yes, what else? So hue is equal to target. This simply specifies the variables in the data frame, which is the DEF data frame. And this will be used for coloring. And it's mostly used for coloring the data points on the pair plots.
Hello.
And remember, the target variable is simply a categorical
Hello.
variable. And this simply helps us to visualize
Hello.
and distinguish between the different groups of categories in the plots. Okay. And please, if
Hello.
I'm speaking and you can't really hear me clearly, let me know. If you have a
Hello.
question too, you can put up your hand so I know that you have a question, then I'll get back to you. Okay. Yes, George, go ahead.
I wanted to know about the hue. Does it map each data point to that 0 and 1 categorical variables also?
Sorry, come again. I didn't get you. Well,
I'm saying that
you said you
does
want
the
to know
hue
more
map?
about the.
Does the hue do some mapping of the the target values to the data frame, the DF. So each one will have different colors. That's it.
No, I think I've just explained this one. The hue is simply just a parameter. It's just a parameter in the pair plots. It's one parameter or an argument, however you call it. And what it does, in this case, it mostly helps for color, used for coloring, and it uses the categorical variables that we have in our work, which in this case represent the targets. Yes. So it means that in the context of what we are doing right now, it's simply a parameter that is used to specify the categorical variables that we have in our work. And this categorical variable is simply the labels that we have. So here it's simply used to assign different colors to the data point in the pair plots. Do you get it?
Oh yeah. So it's basically
Yeah, thank you.
It helps to differentiate between the two other variables using the color. But Prince, one thing I don't understand.
Exactly.
One thing I don't understand is that
Yes,
when we are in the previous graph in the histogram, we use the remaining features and then target was in the x-axis. But then suddenly here, when we do the CBAN of the pair plot, I see that the target is actually being used to identify, using the hue to identify the relationship between the remaining. So it's no longer on the x-axis. You see here, target has been used as x-axis, yes.
Where you mean
In some of, go
on this
down.
graph?
Yeah, here, on this graph. The one down, yes. You see, a bit down? No, you're going up, down? Yes, down. Where we use the subplots.
Yes, the subplots.
Yeah, the target is used as the y-axis and the x-axis, sorry, right?
Yes, this is simply a label. It's a label. So for instance, what's the name? Okay, so let me just make it Prince. So if I type Prince here, it's simply a label. It's not. So if I run this, I'm coming. Oh my God, let me see.
No, Prince is not in the data frame. Target because it's inside the data frame. That's why it's using it on.
Yes, let me check something. I think I'm doing something wrong.
In fact, even in the histogram, target is on the x-axis. And what worries me is that in target is only taking values 0, 1, 2, and that's it. But in some of the places, target goes even until 7.
So the Sn dot violin x equal to df dot target with it aligns that simply plots I think they simply plot the different continuous variables that you have. Let me see something. I'm doing something wrong over here. Okay.
Yes, even if you look at this figure.
Yes, so wait a minute. So it simply means that we are taking the categorical variable, that is the labels. So this plot is simply against, you are picking the petal length. Can you see the image that I have here?
Yes, that's correct.
So from 0, 1, and then 2. These are simply labels of the names of the targets that we have, the 3 different labels that we have. And that is represented on the x-axis. Do you get my point?
Yes,
This
yes.
is represented on the x-axis. And then the petal lengths are represented, the petal length and then the petal width are represented on the y-axis.
Yes.
So if you plot this, it simply picks the first subplot, and then it's, for instance, the first one, you are plotting all the targets, that is the label against the petal length. So he picks each name of the flower that we have, and then it plots that against the petal length. That's exactly what this plot is doing. If you go to the second image, it's picking the labels, that is the names of the flowers that we have, and then it's plotting that against the weight, the total weight. Do you get that size? I mistakenly, this is a very good question actually. I thought these things here were simply variables, but df dot bracket simply means that it's picking something in the data frame. It's picking a column in the data frame. So if you go into this particular, if you go into the data frame, so df dot target will pick this column. Df dot target will simply pick this column. So if you print this, so for instance, if you do df dot target, they should print that particular column. I mistakenly did something wrong. So I realized that it's giving you an index and then it's printing that particular column. So if you come here, it simply picks all the values of that particular column, and then it plots it against the petal length, and it does that for the, it uses the target and then it plots that against the petal length and petal width of the respective labels that you have. I don't know if that's your question, the question that you asked. So it's actually not a label, it's simply a column in the data frame.
So then what is the decision that, how do we decide that which column is going to be on the x-axis? What makes you decide that target has to be my x-axis for all of them?
Yes, because that's what we want to visualize. That's what we want. For instance, if you switch them, it simply means that, and remember this categorical variable. Do you get that? This what we have here is simply a categorical variable.
Yes.
So that's one of the main reasons. So you are picking a categorical variable and you want to know what are the specific features governing these categorical variables, which are the labels. And I told you that this violin plots that we have here has special interpretations, and that has to do with the median, the maximum, the quartiles, and all that. So you can, if you interchange this, it's going to be a lot of problems. I hope your question has been answered.
Yes, thank you so much.
So to simplify, you know, what what this code is simply doing, I don't really know your name actually. The code simply generates a figure with 2 by 2 grid of a subplot. That is the first one. And then the second one, each subplots are simply displayed in a Boolean plot, which is simply a way to visualize the distribution of a continuous variable across different categories or groups. You get it, and you realize that this petal, the petals and the sepal are simply continuous variables. And so we are plotting these continuous variables, and in fact, it should be on your y-axis because these are continuous variables, and then you're plotting them against a group, and in this case, being your categorical variables. So it's simply a way to visualize the distribution of a continuous variable across the different categories of group. And this group in this case is represented as target, which is given as x. I mean on your x-axis. So the plot simply shows how the length and then the weight of measurements. Take note, the length and then the weights of measurements in the respective codes that I've given there. And this is taking the petal and then the sepal. And you have to also take note that this actually varies for each species in the data set. So if you check carefully, you realize that the first one, it ranges from 1 to 7. And the next one, the petal weight ranges from 0.0 to 2.5. So these are simply continuous values in the data frame. And we are using the target to look out for some specific features governing these labels. I think I'll spend so much time on this. Yeah, is there any other question? That was a very good question, actually. Yes, can I proceed? Yes, the plots will now have actual names of the target variables instead of. Yeah, this is simply a way to encode the categorical variable in terms of numerical variables. I hope that's fine. From what's that question? Yes. I think I've already explained the pair plots, right? So let me quickly go into the heat map, which is simply a way to visualize the correlation between the variables in your data frame. So you realize that this is using the Seaborn package, and you pass the data frame and you cause the method correlation method. And this finally plots out all the features in addition to the target, and then it gives you the one that are strongly correlated and I mean positive correlation and negative correlation. So what this thing this picture is telling you is that you can simply look at this and then drop some features that wouldn't be relevant in your analysis. If you look at this one, you realize that there's a very strong correlation between the petal length and then the target. It is 0.95, and there's a very strong correlation also between the sepal length and then the target. But if you look at the sepal width, the correlation is actually negative. It tells you that it wouldn't contribute that much to the performance of the algorithm that you are coming to build. I hope that's clear.
Sorry, Prince, you said that which one that affect the performance of the algorithm?
What I'm saying is, if you look at the correlation between the features, you realize that there's a strong correlation between some of the features. There's actually a strong correlation between the petal width and then the target. So if you pick this one from petal width and then target, you realize that the correlation between these two is 0.96. The correlation between petal length and then target is 0.95. Correlation between sepal length and the target is 0.78. But if you look at the correlation, for instance, between the sepal and then the target negative 0.43, same thing between um, sepal again, I mean, you are getting negative correlation there. So it simply means that it's not talking about it's reducing the performance of the algorithm. It means that it doesn't really contribute much to the output of the algorithm. Do you get what I'm trying to explain?
Yes, yes, yes.
Yeah.
But then if we look at the color that toward the bottom there between
Come
petal and
again?
sepal, yeah, like here. If we look at the colors that next to, I mean, from target to petal length. So you see that the color
From
is,
target.
yeah, to petal length. So the color is much thicker in blue. Does it mean that is a petal width is the one that contributing the most?
No, the color simply tells you is simply a range from negative correlation from weak correlation to strong correlation. So that's what is illustrated here. It tells you the strong correlation and then the weak correlation. And now,
Yeah.
in correlation, I think there are four types of correlations. You can have, um, I think, positive, negative, and then strong and weak. Also, I can't really recall the statistical times, but I think there are four types of correlation actually. And if you look at this, it simply giving you a range, which tells you um, the correlations that are strong according to the colors that have been illustrated in the heat map. Is that clear?
Yes, thank you.
Yes. So df dot correlation, I've already explained this, is simply a function. It's just a correlation matrix. It contains the correlation matrix, and so this ANN not is equal to true is simply a parameter that specifies whether to display the correlation value in the heat map. Sometimes you wouldn't want to display this on the heat map. You just have to put it to false, and then it will not display the correlation values on the heat map. But if you want to display the correlation values on the heat map, you just have to set it to true. And the CMAP radius is simply a parameter that is we normally set to color the correlation, the heat map. And the radius is simply a color map. So there are different type of colors that can be used to color this. Is that clear? Let me quickly move to train test or split. I think they took you through all these things again, so I'm just going to speed up. If you want to learn
Hello,
more
Prince.
about how to train and then how to split the data sets, there's a link here. You just simply use this link to learn more about train test split. Okay. Yes, is there anyone? Is there any hands up? If you have a question, just put up your hand and I'll call you. Yes. Yes, I'm listening. Who has a question?
Yes, Prince, I have a question.
Yes.
Yes, about the correlation. Can you go up there?
Yes.
Here we have our target variable as zeros, 0, 1, and 2. And those are considered to be labels of our target variable. So my understanding is that those are the labels, and does it make any meaning to find the correlation with those labels?
I don't get you. I don't get you. Come again.
Sorry?
What did you say? I didn't get what you said.
Yes, I'm asking, like, those labels, like I think 0 is representing something like those labels are actually representing the categories of our target variable. So I was asking if finding the correlation using
Yes.
those labels, does it make any meaning out of it?
Yes, it makes meaning. It simply tells you, are you talking about the features?
Sorry?
Are you talking about the features? You mean the features of the data sets?
Yes, about the target variable, the target.
Yes.
Is it not the categorical variable?
No. In this case, we are not using the categorical variable. We are just using the one that has been encoded.
Yes, I'm like, after encoding the categorical variable,
Yes.
does it make any meaning by using those labels to find the maybe summary statistic using those labels?
Yes, absolutely. It makes meaning because even though we've encoded them, they still carry the information, the necessary information that you want. So 0 means something, 1 means something, 2 means something. So the target variable still host all the information, even though it has been encoded into something different. So it has a meaning.
Okay, thank you.
You're welcome. Yeah, so it simply means that the strength of the correlation ranges from -1 to +1. So a negative indicates a perfect negative correlation, where positive indicates a perfect positive correlation in that sense. Then within the middle, there's weak correlation, and then strong correlation. But then positive one and negative one are both perfect positive correlation, and then perfect negative correlation in that regard. So Let me quickly move to. So if you want to read more about how to test, train, and then test your model, you just have to use this link to learn more about that. So train, test, or split. We want to split the data set into training and then test, and I passed all the data frame into it, and then I set the test size to 0.3. You can still decide to use the train size and then use test, set the test size to be maybe 80%. So if you are working with a huge data set, it's mostly advisable to use the training set, yeah, the percentage of the training set to be around 80%, and then you leave around 20% for testing. But then if your data set is not that huge, you can do 70-30. So you work on this, is you save everything into this variable. And remember, this thing here is simply giving you two different things. So you are saving one in the train and then you're saving one in the test. You can just plot this thing out and then it gives you the shape of the. So 70% for training and it has 105 rows, 20% for testing, it has 45 rows, and both has 5 columns each. So this just is a way of preparing your features and then your targets to be used for training, as in the specific features that you want to assign to your train, and then the specific one that you want to assign to your test. So you go ahead and then this line simply prints out. Let me run this. Run this. Run ahead. Yes. So now we are done with everything. Now we need to look for an algorithm and then implement whatever we've saved. Implement everything on an algorithm. Evaluation matrix. This is simply a matrix that helps you to assess the performance of the algorithm. So accuracy in this case represents the true positive values and then true negative value. You divide that by the total length of the data set. True positive and true negative are uh, okay. Let me explain this. So, for instance, if you have a target variable that has to do with cats and dog, true positive simply means that okay. So let's take your the number of dogs being the positive values that you want to predict, and then anytime the algorithm predicts something else, that will be referred to as negative. So true positive simply means that the algorithm was actually able to predict values that are predicted correct values to be correct, and then true negative simply means that values that were negative, it predicted them to be negative. So false positive simply means that the thing is true, and then the algorithm predicted it to be false. And then false negative simply means that it is negative, and then the algorithm predicted it to be negative. So you can read my recall. Recall simply tells you what proportion of the actual positive was identified correctly. So this, you use the true positive rate, and then you divide that by the true positive rate as the first. This thing is simply called a confusion matrix. So it mostly comes up when you are doing machine learning, especially if you want to assess the performance of your algorithm. ROC simply refer to operating characteristic curve, which is also used to assess the performance of the classification model and it has this. It has a shape. No, do I have a shape like that? I don't have a shape like that. So I'll leave this to you if you can still read more about this thing. And the ROC and AUC, we normally use them together. AUC simply means that area under the curve. And if the area under the ROC curve is huge, it means that the algorithm is performing well. If the area under the curve is not that huge, it means that the algorithm is not performing well. So simply the AUC ranges in the value from 0 to 1. So if it's approaching 1, it means that the algorithm is performing well. If it's less than 0.5, it means that it's not performing well. So it simply means that if a model has a prediction accuracy of 100% wrong, has an AUC of 0.0, that means that if the prediction accuracy is totally 100% wrong, that means that it's 0. Then it means that the AUC is 0.0. If it is 1, it means that it has a positive prediction accuracy of 100%. Yeah, so I didn't explain into details. If you want to understand the true positive, false positive rate, and then accuracy, precision, recall, ROC, and AUC curve, you can use these links to learn more. You can also watch this video from this Professor Doshi, he will explain more thing about the ML robustness too as well. There's another metric called the F1 score, which actually assess the performance of the individual classes. Yeah, so if the model is able to predict the classes correctly, you normally use the F1 score to assess that. You can read more about that too as well. So basically, we are going to use the k nearest neighbor, and the k nearest neighbor simply works with the idea that we have the centroid, and to use this centroid, you choose the centroid, and once there's for instance, if you look at this image, you have blue boxes and then red triangles, and we have a point that is closer to the red triangle. Then you realize that this is within the first radius, and then we have a larger radius. So because this red triangles are closer to the centroid that we have here, it means that this green point will be classified as red triangle. So that is the whole idea of k nearest neighbor. It works based on radius and then a centroid. Kind of uses the idea of k-means actually. So if you want to read more about k nearest neighbor, you use these various links. You can read on sklearn, you can also read on KNN from YouTube. So go ahead and run this cell and simply run this cell, and then it gives you the number of the radius, the radius size that you have. K nearest neighbor classifier, which we've already imported already. Then you fit the model, you call the model, then you fit it to your training sets, and then you pass your training data set into it for training. Then these particular lines of code simply mean that the algorithm is being trained on the training set. And then after the algorithm is being trained, you want to now test for the accuracy of the algorithm on a data set it hasn't seen before. So that is why we pass the text X through the algorithm to assess its performance. So I have some questions here. What if you try with different k values? What will happen? And if you try with different distance metrics, what will happen? So you can do that on your own and then access the outputs. Now let's assess the overall accuracy of the model and realize that the overall accuracy is given as the overall accuracy I'm getting 0.97%. The precision is 0.97%, and then I'm getting the record to be 0.97%. And this because I'm using a distance metric of 10. So I think you can check that. So I'm using different distances, these radius. And there are three questions here. What does the accuracy, what does the, what is this thing? So, this thing. Yeah, so what does the precision score mean here, and what does the record score mean here? So yeah, the accuracy simply tells you the overall performance of the algorithms. Are there any questions in the chat? Yes, who has a question? I think someone tried speaking.
No, I was trying to see where was the confusion matrix used.
You mean, come again?
I'm saying where did the confusion matrix, where was it used in that? Is it inside where those true positive and
Is
true negative?
it?
The confusion matrix, where was it used?
Yeah, I've not printed out the confusion matrix. I didn't print it out on this. I just printed out the accuracy of the model, and then the precision, and then the record. Yeah.
Okay.
But mostly after assessing the performance of the algorithm, you would like to check what the algorithm predicted accurately, and then what it predicted wrongly, using the confusion matrix. So you can try it out and print out the confusion matrix, or maybe I'll do that in office hours, probably on Wednesday. That will be fine with you.
Yes, that's okay.
Okay. So the next one is the logistic regression model. My time is up. I'll be stopping very soon and continue hopefully on Wednesday. So let me quickly talk about the logistic regression model. The logistic regression model has the idea that it uses the Sigmoid function, and if you it's cutting and it is low than 0.5, it just gives an output of 0. So if you want to read more about logistic regression, and you can use the three links here that I have here. So similarly, if you build a model, you just build a model, you pass your training data sets into fit the training data set. Then you just go ahead and then assess the performance of algorithm. I think all these terms have been explained already, so there's no need to go ahead. Yeah, so the next thing that I'll be talking about is so whatever we've done is supervised learning. The next thing I'm supposed to talk about will be unsupervised learning, and then the reinforcement learning. And other supervised learning algorithms, decision trees, support vector machine, neural networks, random forests, SGBoost, and all that. So these are the normal classical machine learning algorithms, and you can try your hands on them since you have this notebook. So on Wednesday, I'll be I'll be completing this session. I'll take you through. I'm going at a very slow. I'm going at a slower pace because I want you guys to really understand each line of code. That is why I'm not really rushing through the notebooks. So if you have any question, feel free to inbox me personally on WhatsApp, or you can ask all your questions in the classroom, and I'll make myself available to answer them. So I'm free this week. I don't really have a lot of tasks on my desk. So if you want to meet me or have any question that you would like to ask, feel free to reach out, and I'll be there to um, assist you. So yeah, so I'll complete on supervised and then reinforcement learning on Wednesday, hopefully. Thank you very much for enjoying this, to joining this class. If you have any questions, feel free to ask them, or I'll just hand over to Eunice.
Okay, thank you so much, Prince. Please, if you have a question, you can raise up your hand or post it in the chat. Feel free to post your questions before we can end the session.
Oh, thank you so much. Great session. So I hope and then yeah, try to read. It seems like there are lots of links that have been provided there. Yeah, homework of reading.
Yeah, there are a lot of links, and this weekend you all guys, you are too cold. I don't know if the session was complicated for you, or I don't know. I don't know what was happening.
No, the session was great. We're trying to just understand it by way, when he's talking of confusion matrix, true positive, true negative, false. Yeah, so
it's a lot of new things all at once. Okay. Before I
Yes,
can end,
this whole idea about the confusion matrix is sometimes confusing. I think that's the reason why they even gave the name confusion matrix. Anyways, it's not that difficult actually.
okay.
We look at some example. I think on Wednesday I'll post the confusion matrix of this algorithm out, and then we analyze it into details.
Okay. Great. Prince Penjani, you have a question?
Yes, thank you so much. Just, I don't know what you've concluded on the material from yesterday, like the links
yes.
for us to be able to access those.
Yes, that's what I wanted to address next, is that do you have access to the folder class resources?
Yes.
Because that's where Damaris puts the PDF slides. Can you open it now and see? Because yesterday she must have uploaded the slides there. Can you please open and see if they're there, so that I can know if the PDF is not there, then maybe there's a problem, but the PDF has to be there.
From my end, it's not there, so I don't know about the other.
Can someone please check because the folder is just for the mentees. I don't think I have access to the folder class resources. Can someone access the folder where Damaris usually puts the videos and the PDFs? At the moment, we only put the PDFs there, and see if yesterday's slides are there. If they are not there, then I should inform her about it. Does someone has the same problem? Please confirm it for me. Because Penjani cannot find the slides, if someone else can't find, and Damaris says she put the slides there, then there's a problem.
Yeah, I think she put them yesterday.
Okay, Penjani, so Ali can find them?
Wait, I mean, is it true that the slides are there, Ali?
Ali, did you see them, or?
Yes, she did put them yesterday, yes, with the Let me get back to. I cannot find it there.
There are no slides in this folder
Mm.
that was yesterday.
Ali, which folder can you find it in yours?
Are you
Which
accessing
of
the
the
class?
folders?
I think Eunice, I think we have to look into this thing again because I have other mentees who reach out to me complaining that they can't really find the slides and then the videos on the shared folder. So I think
Okay, for the videos,
it's a
I
problem
don't.
that some of them are facing. So we
Okay,
can
for the
try and then look
videos,
into.
yesterday I made an announcement, and maybe I will redo the announcement. We usually post the videos in the class resources still, but some students complained that in the class resources we had restricted downloading the videos. And so to make them watermarked, we started posting them in YouTube. And in that case, they can, in the channel which we created, so that they can save them and use for offline use. I think Damaris has put it in the WhatsApp group. I saw the video, Damaris put it there, so everyone should have access to that channel. And yesterday I made the announcement, so I still don't know why they can't find the videos, honestly. Does someone has a problem accessing the videos still?
No, Eunice.
They just don't load fast, but which link that because those links there where they are is hardly to load.
I hope when you search for Gallows Insights, you'll get their videos there and then you
Yes.
download.
Okay.
I've said about
Yes.
the videos. The soft skills.
Yeah, they're all videos are there, and if you just follow the link directly, and we did that because some students do not have internet the whole time and they needed to save them. So we opted for this other option so as to cover the other students that need to save the videos. And, in that way we can put watermarks and make them quite professional. And I don't know why some can still access them. Let me share again the link to that.
So we are waiting for the others, like the and the current ones.
Yeah, yes, like for yesterday, because when we record the videos, some videos have like images, maybe they are being shown, and we need to edit and remove where there's an image and just to show only the classroom. And Damaris will edit like for yesterday's class and upload